record a short video of the Aeroquad UVic quadcopter that Aras and I are building. I've been doing some work on the sensors recently. You can see wired in, oops, I guess I've gone beyond my focus. You can see wired in on the I2C connectors here is a 9 degree of freedom sensor stick from SparkFun. This has on it a gyroscope, accelerometer, and magnetometer or compass. The gyro is one that the Aeroquad project had used previously, and so getting it to work in software was fairly straightforward. The compass initially was straightforward because, again, there was some template code to use in the Aeroquad project, but the accelerometer was actually one that had not been used in the project before, and so had to go back to the data sheet and figure out how to do some code with that. And I also integrated right now a external demonstration application for that, and then I'll work it into the Aeroquad classes a little bit more smoothly later. The only thing in initially installing this sensor that I had a problem with is you'll see two little orange wires coming off the SDA and SCL lines off of the sensor stick. For some reason, those were reversed in order from what the Arduino offers, and so rather than just being able to solder on a simple 4-pin header like I had done originally, I had to put two wires in there to reverse those two pins to get SDA and SCL in the proper order. So next I'm going to put the quadcopter down on the table here and show you a piece of software that one gets from integrating the quadcopter with the Aeroquad software. This is a piece of software called Configurator. It allows you to look at the real-time sensor readouts. You can see on the left-hand side the gyro roll and the accelerometer roll, then pitch in the middle, and the accelerometer z-axis in the middle there as well, and then yaw over on the right, and the compass heading up on the top on the right. Those are the main ones that I'd like you to look at as I go ahead and connect to the Aeroquad. So I'm connecting to COM6, and it should momentarily here give me an error message saying that not all the functionality is supported. We're using a just directly wired set of sensors rather than using the shield that Aeroquad sells, which incorporates a couple more things onto that shield, including a battery monitor, and so not all the readouts show. So we can see a little bit of wobble in the sensors as we just sit here on the table, but not too bad. As I pick up the Aeroquad, and let me, I guess I can't do that too easily in a way that you can still see. So as we pitch up and down, we see the gyro telling that, and then a little bit dampened, the accelerometer telling a similar movement. The yaw is very sensitive. You can see the gyro swinging back and forth on the yaw. And the heading is staying fairly, well, it was initially fairly constant, and now it's quickly running away. So this is the problem that I'm having on the heading, is that it is not consistent for any length of time. Actually, when you look at it in the graph mode, let's look at the heading chart. It's just wandering a little bit right now, and after a while it'll start doing this sawtooth pattern. And so you can see it climbing back slowly. Well, okay, so it's not acting really horribly right now. At some points it's a very short duration sawtooth pattern. Here we go, slowly circling though. I'm not moving the quadcopter, and we've moved from 100 degrees through 360 degrees, and we'll spike back down to the bottom. And so it's doing this slow wave sawtooth pattern. And I think that this is somehow coming in the error correction code. You're not ever directly reading the compass in the current code in the Aeroquad code base. Instead, you're reading the compass and using the accelerometer and gyro to try and correct the compass readings. And I think somewhere in that correction, it's just not working. And it may actually be in the centrifugal force correction from the motors. Since the motors aren't actually running here, it may be that is being corrected for, and there's nothing to correct for. I haven't quite figured out anyways why the compass is not fully working yet. So I'm going to pause here for a minute and go turn off the compass, and then I'll show you a couple other things in the sensors. Okay, I'm back. I've just gone and changed the code and turned off the compass, and now I'm going to reconnect here and show you a couple other pieces of the software. This is again the AeroQuad configurator software and not the flight side of things. Right now, because we don't have the transmitter hooked up yet, we can't actually do the motor outputs from within configurator. But as soon as we have the transmitter hooked up, we'll be able to arm the motors and play with a lot more in here than we are right now. So, looking at a few things on here, the gyro chart, very similar to the way that we just looked at for heading. This actually has altitude and yaw. So as I move the quadcopter, you can see these lines show what the actual readings from the gyro are. We can get a similar chart for the accelerometer. And the accelerometer has a little bit more drift, it's a little bit more dampened, but gives us a lot of the same information. Well, in terms of the way this chart displays anyways. The heading chart is just going to be flat now because we've unplugged the compass. So those are the main charts. We can go and look at the sensors in this mode or in the chart mode. We can also look at some of the control charts, but again, without the motors going in here yet, we won't focus on those yet. One of the views that I really like in this configurator software, although it does demonstrate one of our problems, I'm going to disconnect and reconnect here, and notice what the artificial horizon does as I do that. It goes from showing this large, sorry, it changed pages on me, from this large right-hand tilt to zeroing back out. And now it's going to slowly drift off to the right. Now in between that, of course, it is very responsive in the way that it's reading out the shifts of the quad. And I'll tilt up and down, and I'll see the horizon move there. I won't be able to turn it around because the compass is turned off, so you don't see the compass correcting. But at least in terms of roll and pitch and yaw, it is behaving very, very nicely. Except for that drift. And so I'm not sure how we're going to correct for that that overtime drift. We'd watch our quadcopter slowly sliding off to the side over time. We'll either need a manual correction, or ideally, I believe that the compass is tied in with that correction. But right now, the compass is finding itself thrown off rather than correcting the other sensors. But some way in there's got to be a way of coming to a happy medium to show those or have those correct each other. There's a calibration process that went through with the sensors as well. You turn on the calibration data, and you basically in a level location zero out the gyros and the accelerometer. And then for the magnetometer, I wish I had actually left that turned on to show you this. But to calibrate the magnetometer, you turn it on and then roll the quadcopter in all dimensions until the point here in the center forms a sphere, and that allows it to record every position of the compass. Anyways, that's a short tour through the sensors and how they're being integrated into the quadcopter. Next, we've got to plug in the transmitter into that. Then we can test the motors combined with the sensors, and then we're basically ready for first flight. Can't look forward to that day. Thank you.